All right, great job on lesson 5. Just know that I can see all your progress. It's not like I'm trying to be creepy or anything, but like I can see everything. So if you have a question, something's not working, tell me, and I can actually bring up your exact coding and then tell you what's wrong. So you can email me those questions, or if you want to set up a time to Zoom, you totally can. But hopefully you got it to work. If you follow my thing, it should get you all the way through, okay? So now we're moving on to lesson 6. So this is about functions and top-down design. So we did bottom-up design last time. Now we're doing top-down design, okay? So let's go over the vocab again because these will be on the test. So abstraction, again, that's simplifying a representation of something more complex. Abstraction allows you to hide details to help you manage complexity. Focus on relevant concepts and reason about a problem at a higher level. So let's say you're going to build a house, right? There's electrical, there's plumbing, there's the frames, there's the flooring, there's the ceilings, whatever. So if you talk to a builder, he's not going to explain that, okay, first we're going to put these 2x4s down in this way, and then we're going to, nail the plywood on. And he's not going to go through every step with his crew. They already know a lot of it. Instead, it's going to be something like, let's put down this type of flooring or these dimensions. And then they know all the steps, right? So we want to do the same with programming. Once we get some small part set, we don't have to think about it anymore. If we got a function, right? We had those calls and those definitions. We have a function that draws a square. We know it's set and we don't have to think about it anymore. We can just rely on the program to remember what a square looks like. So again, a function is a named bit of programming of instructions. So we have some that are already given to us, like turn left, all right, move forward, right? But let's say you wanted to move forward 3 times. Well, you can create that command. It's not in the program, but like if you make it, by creating a function, you're creating this command that can be remembered. And then top-down design is a problem-solving approach, okay? So instead of thinking, hey, let's say I want to draw a house with 3 windows and a door and roof, right? So that looks really good on your screen. I like that. Oh, I can go with a big screen now. That's right. Oh. So top-down design would be this. If you saw, in your mind you saw this, and you're like, hey, I want to draw this. In your mind, you're not thinking, oh, I need to move up this high and that high and come back around. You'd probably be like, oh, there's a square, there's a triangle, there's some smaller squares and a rectangle with a dot, right? So what you would do in your mind is be like, I need to program a triangle, I need to program some squares, and I need a dot. And they need to move to different spots. But like in your mind, you're not thinking about like the exact distance and turning right and whatever else. So you're going to break that down into manageable pieces, especially if, let's say, you wanted multiple houses, right? You could be like, well, I need to build 5 houses. Okay. 5 houses, and what does 1 house look like? Okay, so that's abstraction, and that's top-down design as well. Okay, so let's get into it. Ooh, hold on. Oh, by the way, before, I know some of you are like, I got this. Well, wait. Don't do the AP response. Skip it. This will not make sense to you. If it does, you want to put an answer in there, you go for it, man. But it's really reserved for understanding the rubric on the AP assessment. This is not relevant to you, and it is difficult and time-consuming. Okay, but the rest of these I do want you to do. So when you're done, you will answer these. I like to see how people are doing in that way. But let's get into the first lesson here. These 2 modules, and that'll be it. I just need to show you these 2, and then you do the rest. Okay, so we already have, the move forward, left, pen up, pen down, right? So what this problem is asking us to do, identify useful patterns that can be reused and give their own function. Remember that functions are designed to call one another. This is how you create layers of abstraction, okay? All right, so just like the house. If I had to build 5 houses, great. But what's that house look like? Okay, the house has triangles and squares. Okay, great. How do you draw 1 square, though? Okay, so we're going to do the same thing here. Your program should be kicked off by a single call function. All right, so if we're going to use top-down design, it says do this to break down the design into multiple layers of function. Okay, so I'm going to get you started, and then you'll have a chance to try this out. But let me just look at this. So when you look at this snowflake, I guess you would say, right? Think about how you could break this down into smaller pieces. Like if you had to draw all of it, right? Could you break this down into just one? Draw a snowflake, and you're gonna put every single little step in there for that. Remember, we don't even have it right in here. Or does it make sense to break this snowflake into 2 pieces or 4 pieces? All right, and then once you got that one piece, would you break it down further? So think about that. Okay, in this one, you're not even putting the code yet, right? You're going to jump over to number 3 here. Actually, wait. Do I just hit run? I think I could just hit run and finish on this one. Whoa! Oh, hold on a second. Let me look at 3. I thought we answered that in 3. Oh, no. They are 2 separate ones. Okay, great. That's fine. Okay, so in this one, you do need to answer this. So if you want to try this on your own, which I really recommend, you're going to pause me for a second, okay? Okay, so now that you've tried it, you're gonna. I'm gonna go through how I would do it, and if you know how to do this part, maybe you should just skip ahead. But essentially, when I look at this, I see 4 crosses. So what I could do is I could do draw snowflake. Okay, great. See, camel case, lowercase, uppercase, and inside there, I would have to define my draw snowflake. Okay, and inside draw snowflake, well, what would be inside there? Well, my snowflake, I think I can break it down into 4 pieces, and that would be, that would be draw cross, because I look at this as 4 crosses, personally. Okay, draw cross. Okay, and I'm going to probably draw that cross 4 times. Boop, boop, boop. Okay, because I need 1, 2, 3, 4 crosses. All right, great. But wait, what's a cross look like? Okay, so now I'm going to put a definition for the cross. So what does a cross look like? Oop, better actually, I have to say draw cross. Ooh, lowercase, draw cross. I'm liking this too much. I apologize for my dorkiness. So what would a cross be? Well, maybe we could start putting turtle functions in there now. Okay, so if I look at one cross, well, I think it's going to start with a move forward. In fact, I think I need to move forward 3 times. Okay, so let's look. Whoa, what happened? So to make this a little simpler, you know what? I'm going to take these out for a minute. Boop. And I just want to get one cross drawn first. So let's hit run. Great. Now it looks like I need to maybe turn around and go back, right? So after I get that far, oh, you know what? I'll explain this in a second. I'm just going to do one move forward. I just want to get to the center of this cross. You know why? Because I can do one here, one there, one there. Remember we did down and backs? Wasn't that fun? All right. So I'm going to put another function in there called down. I'm going to call them down and backs. DNB. All right. So then what I can do is create another function called DNB. You can call it whatever you want. You can call it Bruce. Go for it, man. But my down and back is going to be what we said before. It's going to be a move forward, and then it's going to turn around by doing 2 lefts, and then a move forward again. Okay, so let's run this bad boy and see what happens. Ooh, it went down and back. Ooh, maybe I need to turn, because I don't want it to draw over itself. I want it to draw over here. So maybe let's put a turn left before that actually happens. Let's try that. Ooh, look at that. My down and back worked. Let's do 2 down and backs and see what happens. All right. Run. Woo! Let's do 3. Run it again. Okay, cool. So now we got to get back to the beginning if we want that cross to get there, okay? Now, some of you probably would have done this different. You would have started with drawing a cross and then make the functions, but top-down design does work, okay? Okay, so my down and back works, but then we need to get back to the beginning. So I'm going to go ahead and wait. I think it asks us to do the turn right. Maybe it doesn't. That's okay. We don't need it. Okay, and then we can put a turn left in there and then have it go forward, forward again. Forward, forward. So it gets back to the start. Let's run it and see. Oh, that is beautiful. Beautiful. All right, so we know we have to draw more than one cross, right? We did one successfully. So let's paste it in there a few times. Paste. Will it draw 2 of them good? Oh, yeah. Oh, yeah. So let's paste in all 4. Okay, now when we do this, you're going to see something that, hey, Draws once, draws twice, draws 3 times, draws 4 times. We need something in between here. We need to maybe turn left in between because we have to have it turn. All right, let's try that. Boop, 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 boop. Yes. And then we need to finally have it turn right. Or we can do 2 lefts to get it back in that original position. Okay. But again, maybe I want to make a function called right. And so I could put that in there too. We do want it to turn right. Okay, but hey, where's that definition? You can't just put right in there because it doesn't exist right now. Right? So I'm going to create a right definition. And I could do that anywhere, actually. I could just put it in here even, right? Right. And we got to put our 2 lefts in there to get it back to the start. Left and left. Would it have been easier just to put these 2 lefts right here? Sure, absolutely. But I think it's going to ask me to make sure I have it right in there. It is a thing of, oh, I guess I have to go right another time. Right? I guess I should have just done left. Oh, turn left 3 times. Not, I did it twice. All right, let's see if that does it. That's what I'm talking about. Pow. Finish. Yeah, I got it right, and I'm going to heart it. Booyah. Okay, we're going to revisit a familiar problem. Drawing the 3x3 square as efficiently as possible. The only difference is this time you will be armed with the ability to create layers and functions. Remember last time it took like 60 to 120 steps or lines of code? It won't take that long. In fact, I think I've seen students get down in the low 40s, even upper 30s. So we should make it a competition. Who can get the lowest? So it's got to be to the right of this guy, and it's got to end in this spot too. Okay? So in your mind, how could you break this down? What do you see? Some people see 1 square and a row of 3. I got 2 functions right there. Draw a row, draw a row, draw a row, or draw a square and then have it call a bunch of times. Or some people see it as, hey, there's a square here, there's a square here. There's actually, what you're looking at is 4 bigger squares. So if you want to attempt that, it's actually, I think that's the most efficient way to make this thing. But it's got to end in the same spot. So if you don't remember, just to get you started, if you're struggling right now, you're like, Mr. Raymond, then how about we just make a square? So we know we got to move forward, and we want to turn left, but turning left 3 times, I think I want a function there. So I want it to turn right. So I'm going to say, you turn right, but you got to tell it how to turn right, right? So I'm going to put my lefts in there. So 3 lefts make a right, not 2 wrongs make a wrong, right? I don't understand. All right, let's see if that works. Oop, got to name it right. Right. Okay, let's see. Ooh, yeah, look, it went right. All right. And it looks like he needs to move forward, and then he needs to turn right again. So actually what you can do is you can even just highlight these 2 puppies. Paste, paste, paste. Let's see what that does. Ooh, it did it. All right. So right now I have a square. So what do I do? What do I do with all this? Where do I put it? Okay, now here's a mistake some people are going to make. They're going to grab all of this and put it in there. Don't do that. Instead, make sure you only move what's relevant in there. Okay, that'll still work the same. But the nice thing about it is I can call this square, for example. Or really, I guess I should be proper about it, draw square, because that's what it does. And I need to call that draw square. Draw square. All right, let's do that. Oh, I can't spell. Draw square. Oh, I don't know how to spell, so we're just going to go with my spelling and see what happens. All right, there we go. So we have draw square. So now, like, you can decide, like, hey, draw square, that's great, but do I want to draw 1 square? Do I want to do rows? Would I want to make more layers of abstraction like that? Or do I just want to use a bunch of draw squares and my right, and I'm all set? That's going to be up to you. You really should probably use 3 functions at least, though. Okay, so your assignment is to finish this, make it right, and submit that part, and then, yes, finish the questions. Please skip 4. Don't do it. All right, just go ahead and do all the rest. I hope you found this video engaging. Please like and subscribe. Just kidding. How do I stop recording? Where's the thingy that stops the thing from why? I can't stop, guys. What is going on? I'm so sorry. It says, oh, there's my thing.